That's so see why trees and what is trees. See, after reading English, right? So there's you can create many data structures out of it. We created Slack.
Yep.
Now basically with the it's sort of a linked list only. Like a tree is like look like this. This is a node. This is a linked list only. But there are now
Hmm.
I'm talking about now binary trees specifically. We'll talk
Okay.
about end trees as well. But yeah, binary trees first. Let's try to get the gist of it. Okay, what are trees are? Binary trees means like every it's a node. This is called a node. Like whenever in our linked list also we call a node. This is also a node here. Basically, there are at max there could be two childs. This is it look like. It could have less also, but at max it could have. So this is a tree.
Okay. Okay.
So basically, this is a tree. Let's try to get into the terminologies. So this whenever there is a top of the node, right? This is something known as the root of the node, root of the tree.
Yep.
Sorry, root of the tree. This is called an edge. Edge basically between two nodes. So this is known as link, you can also say, but more specifically, like in terms of trees, graphs. So basically, this is known as an edge between two nodes. So basically, this is a directed edge. Basically, it's not back. You can't traverse from here to back, right? There's a one way
Yep.
only. So yeah, this is this and nodes we discussed. This is and whenever this is a node, if I just talk about this and this, basically you can say this is a parent. This is a parent, and they are the children. Children. So basically, they are children and they are parent. This is a single child. This is a parent of this. And This this parent, his parent is him, and like that. So you can define whoever is above is a ancestor. Now, you what is the relation between this and him? So basically, he is the ancestor of him. So this is a terminology basically used in trees. So yeah, immediate is a parent, and if you go above in the hierarchy, this is an ancestor.
Yep.
So yeah,
Yes.
yeah, like the same family hierarchy, grandfather, and then nephews and all. So yeah, this is similar tree concept. So okay, so now how to make our tree? That's our a big question. Is like how it's look like and how to define the class for that. So let's try to understand it. So
Okay.
making the tree. Let's try to understand what we require. So whenever you are building a data structure, right, you just focus on one node. On one node, what you require. Let's try to revise linked list. So what's basically what we require? Data and a null node because this much the next node you can say. Like if you talk about one node, it should look like this. A data required and a next node required. Similarly,
Yep.
here in a tree, what you require is a circle. Basically, there's a node. There are not one link this time. There could be at most two links, right? It could be null,
Yeah.
but there could be at
It
most
could
two
be.
nulls. So basically, we have to write like this class. Two things we require: left and right. Last tree. You can say tree node also. Like some people say tree node. So tree node. Tree node. So basically, we obviously data. So we require data.
Yep.
And then there is something known as tree node star left. Tree node star left. And there's tree node star. All right. This is how we require a tree node star left and a tree node star right. And then obviously let's try to make the constructor. So tree node,
Mm-hmm.
we will be given a value into L, and then we are very much familiar now what to do. Just nothing. Just our data. Data is equals to val, and then nothing. Initially, let's initialize with null only. There are no children. So left is equals to null, right is also equals to null.
Okay, okay.
This is how we can make it, and this is a node created. Now, similarly, we have covered linked list, so basically we have a fair idea how to connect nodes. So let's say we have a root node. Now there is no head node. We the terminology changed to root node. This is a root node, and you connect its children. You this one and maybe left it empty. Null. Let's try to create it. Let's try to see it. Oh, so, so yeah, let's try to create the class class tree node and here yeah, what we need, let's make it public everything. Yeah, three things we require in data. Tree node star left, tree node star. Do you know have an idea of recursion, by the way? How does that work?
Uh,
Basic idea, or I
yes,
should let's go through that also, because that's a very basic required for this. Not able to understand how
sure.
recursion works, so it would be very difficult in the traversals.
Yeah, that's true.
So in data left, right, and then let's try to make the constructor three node well, and so basically this what data is equals to val, and then left is equals to null, and right equals to null. So yeah, this is how, yeah, you can make this also, this dot left, this is also fine. Like both ways is fine. Like you can do this also, you can do directly also, because there's no same data name, right? So it's not a problem. If I just wrote here this, because suppose if this is also data, then it would be
Yep.
a confusion, right? That's why I write this. So it's not required, but yeah, it's a good practice to write this. Why? Because it will able to understand. Okay, you are talking about class variable names, not the parameters or anything, right? This is a good
Yes,
practice to
yes.
write this thing. And yeah, this is the node we created. Let's try to create node. So we node root is equals to new the node. Let's say what three nodes are equal to your root run, and then let's try to connect its left child and right child. So three node star child one is equals to new three node two, and then three node star. It should be star three node star child two is equals to new three
Yep.
node. Yeah. Now let's try to connect them. So yeah, now what we have in our I have created like this. Basically, we have similar to linked list. One we have nothing null null. There are three separate nodes now. Similarly, two null null and three also are null null null. I now need to connect like this one to two. Then it should be a null and null, and a three and a null and null like this. I need to connect. Let's try to do. So here what we have to do, root dot left is equals to child one, and similarly root dot right is equals to child two.
Okay, okay.
This is a basic thing. So yeah, we have created these things now. Every time, yeah, whenever we create a data structure, there are two, three things we talk about. Obviously, uh, whenever we create a data structure, how we will traverse it, because that's what we have created, right? So we can traverse it. So data structure, not traversal. This makes two things. Data structure. So we have to do a traversal, go through the node, the efficiency in terms of two things, time and space.
Yep.
Could be time and space. This is basic look like. So a general tree, if I just we already draw it, let's try to draw it again. And it could be like it could be anything like this. It could be very big as well. This and this. Whenever I'm not drawing anything, suppose they are null nodes. Okay. So like it could
Okay.
be like this. It could be like this. This is a very skewed and whatever complex tree. We have to make it, and also how to do that. Before that, let's try to revise recursion. It's very important here. So, yeah, how recursion works. Recursion. So basically, what happens is, so basically recursion is a very crucial tool or very important tool because it helps us to you solve a problem for one case, and the recursion will like the computer will automatically solve for the other problems. Like suppose I will give you an example. Suppose you want to calculate the sum of n natural numbers. I gave you a problem.
Okay.
Just a second. Uh, Okay, just give me this there. First, ah, mm, wait just a second. Yes, basically, we have got a problem to calculate using recursion, calculate the sum of first and natural one. There is one thing you can do. You have known the formula also, I guess, n into n plus 1 by 2.
Okay.
You know this formula, right? I guess.
Yeah.
Okay, so this is one way. Or other ways, you are a coder, so you can write a for loop. Int I is equals to 0, I less than n, I plus plus, and just you should start from 1 and equals to n, and just you do sum plus equals to uh, I. That also a way, right? Just go through the loop and calculate the sum. Now, using recursion, how we do that? See, there is a func we call function with the int n we
Yep.
call. And then how it works, let me just write the code for you. See, you know the sum for let's say n equals to 0 or 1. We already know that if n equals to 0, what is the sum? 0 only. And for n equals to 1, we know the sum is 1, right?
Yep.
We know these things. So we that is known as a base case. Like there is a template for recursion. So basically there is known as a base case. Base
Okay.
case.
Okay.
So suppose for that, maybe base case is like a trivial problem that we already know the answer. Trivial problem. So like if I already know if n equals to 0 or n equal to 1, I know the answer. It is n only. Like you can say right directly. Or like you can to ease out the process directly. Let's try to write this also. It's very easy. Don't need much.
Okay.
Directly you can write if n equals to that also enough. N equals to 1. That means we know that we have to return 1. I will tell you why I'm returning and everything, how it working. If return one means the answer is one. Suppose whenever I am returning, obviously I'm returning the answer only. So I know the answer when n equals to 1, the answer is 1. Okay. If it is not, then what
Okay.
I'll
Okay.
do, let's say I need to calculate if n is not equals to 1, then it won't go here. So what I'll do, I will add this n and then I will call our function for let's say n minus 1. So basically, what I have done is I have calculated this number, and the for n minus 1, he will give me the results. Let's suppose how it works is like that. Suppose I need to calculate for n equals to 5. Let's say sum of first 5 natural numbers. So what I will do, I will calculate 5 and then I will call the function to calculate the sum of first four natural numbers. Okay, so
Okay.
5, so I added it. Sum 4. I'm assuming, this will return me the answer. This will, it's a very interesting concept actually. You will deep dive into it, how it is working, because this is a very crucial part. This will return us first sum of,
Everything is okay?
yeah, ma'am.
Everything is okay for you?
Yeah, it's fine. There's
Okay,
anything
please
else?
continue.
Yeah.
Nah, please continue.
Natural number.
Mm-hmm.
So, yeah. So this will sum of return and us and first natural numbers. First four natural numbers. I'm assuming it. Like in the computer, it will do it. I'm assuming it, and then I'm returning this answer. Okay. So how it works? Let's try to understand. So I call the function f5, function for 5. Okay. So internally it will
Yep.
call function of 4. Internally it will call function of 3. It's a stack. Basically, I will tell you how it works. So basically, they will call till the time I reach the base case. I reach the base case here, n equals to 1. And for n equals to 1, I already know the answer. It is 1. Now,
Okay. Okay.
now my computer will understand, okay, oh, I have reached the base case. I know what I need to return. So I will return a 1 here. Okay, I return a 1. Great. Get function 2 depends on what? Function 2 depends on, we wrote the, this is something known as a recurrence relation. So I wrote whatever here is a recurrence relation. Answer is equals to n plus f of n minus 1. Basically, you can say that uh, this is the idea, right? Let me explain it.
Yep.
F of n is equals to f of n minus 1 plus n, right? Because this is the sum of natural numbers. Basically, you just add till n minus 1 natural numbers and add a n to it, current number. I'm using the same concept. I returned the one. Now two got from whatever he was wanting, and then he returned and also. So when he is returning 3, he will return what? 1 plus
Okay.
2. Because 1 to already got, and 2 extra because of n equals to 2. So basically he will return 3. 2 func 3. Okay. Now what happens to func 3? Now func 3 will return what? Func 3 will return func 2 plus 3. So func 2 we already calculated. It is 3. So 3 plus this 3, it will return to func 4, and then fun 4 will return to func 5. Is like 4 to this 6 is, we got it here, 6
Yep.
plus 4. Okay, and
Okay.
then
Okay.
5 will return us 10 plus 5. So this is how we got the sum of first 5 natural numbers. Let's try to see in the code as well. Yeah, this is like very important thing. Let's try to int some in, let's say fun only. This means fun int n. So what I'm doing, I'm writing the base case n equals to 1. Let's try to return it 1, and if, yeah, nothing else. Now I'm storing answer is like n plus f of fun of n minus 1. I'm calling the function in itself, basically. I'm calling the function in itself. This is all called a recursion. In a function, I'm calling the function again. And
Okay.
return answer, basically. Yeah. Let's try to see it. Okay. So fun, let's say 5 only we called. What it gives us? 15. Okay. So let's try to write for 2. And it should give 3. So yeah, this is how we calculated the sum of first n natural numbers using recursion. So I don't need to calculate for all numbers. I don't know the answer. I just know this is a recurrence relation. This recurrence relation you need to formulate somehow, and nothing else you need to do. And this return answer you have to do because here the and you have to write this base case. There are two things you need to understand. Firstly, base case, what trivial answer you know, because there is need to be a stopping condition, right? Because let's say
Yeah.
I don't have any stopping condition, it will go forever. Just call the functions and all. Maybe till in minus infinity it goes. So there should be a stopping function. So there, here we reach here a base case. So this base case need to be defined. This is known as the recurrence relation. Recurrence. Recurrence relation. So yeah. So this is we have done. Now similarly, what in the case of any traversal of trees and all, right? What we will do, let I will give you an example. We will discuss in the next class. I think we are running out of time, but yeah, let's try to understand. I will write the code to try to grasp it, and we will try to dry run this code. Okay. So what I will do,
Yeah.
I'm writing a code for let's say pre-order hours. Pre-order, pre-order drops. What is pre-order means? Pre-order means root will come first. Root, left, right. This is the meaning. Code writing is very easy. I will write the code very easily, but understanding it's very difficult. Not difficult, but it's not trivial. Let's try to write it. Void. What I need. Okay, let me just write the function name as well. Void maybe reorder. 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 And we need a tree node star root. Tree node star root. Now, let's try to understand what could be a base case in a tree traversal. There is a tree.
Yeah.
There is a tree. There is a null here, and null here. What could be a base case? What do you think? Like, what is the stopping condition? Like, when I don't need to
Um,
traverse more down.
Sorry, wait. What was your question again?
My question is, like, what could you think? Like, when I should stop the traversal in my tree? Like, when I reach which node, which type of nodes? So I don't need to go down.
Hmm. You need to basically go all the way till N?
Yeah, like you need to traverse all the nodes, right? But when let's suppose you're traversing here, and you reaches a null
Yeah.
node. Now you can't go
Yeah, so
down, right? So
yeah, you
basically,
can't go, so you go up.
you can go up, but
Hmm.
you have to return from here, right? You can't go more
Oh
down.
yeah.
So the
Yeah.
basic idea is whenever you if root is become null, if root equal to null, that is
Yep.
our base case. So we just return from here. Obviously, we'll go up, but we just return from here. Okay. Now, what is pre-order means? First root will come. So let's try to print the root out. Root
Hmm.
dot data. I will explain this code in the next.
Okay.
Let's just try to understand it what I am writing here. And then
Yeah,
okay.
sure.
And then what we'll call? We'll call left solve sort of pre-order. Pre-order. We don't need to do anything. It's very simple. Root dot left. Call root dot left. Recursion will solve the case. We solve the case for this thing. Pre-order.
Okay, okay.
Pre-order. Root dot. That's all. So firstly, the pre-order means firstly root will come, then left will come, and then right will come. The root we have printed, pre-order we call for the left thing, and then we call for the right thing. So this is a simple code of the order. Now, how it is working, how it is calling, and what is the flow of the code, we need to understand it, and everything we will understand. Basically, this is the thing. Okay. This is the thing. Okay, let's try to write the code for post order. What will be the change? Try to write the post order traversal. Nothing changes. Code wise is very easy. Traversal. If I just write so So, yeah, void post order. And we got a tree node star root
Okay.
again. Now, what is post order? Post order is left, right, and then root.
Okay. Okay.
That is the order. That's only the order changes. Firstly, the left will come, then right will come, then root will come. Then similar base case would won't change. Right? If root is equals to null, then we will return. And if it is not, let's try to forcefully call the left. So post order. The order is very important here. The order changes, your printing statement changes. The call of function changes, right? So yeah,
Yep.
this is post order root dot right we will call, and then we will print the date, whatever is the date. Actually, the root itself is changing again and again. That's why I'm using the root only to print the things. So count root dot data, root dot data. Yeah. So basically, this is the thing. What we have done today is very important. So firstly, though we discussed the assignment only. It is a trees assignment. Though I think we have discussed is good in good way.
Yeah.
How so we debug something and we just take the strings and all. And the major thing we discussed today is the trees part. So trees, I told you about edges, nodes, children, parent, root of the tree. What is the root of the tree? How is going traversal? See, I am saying this is a root. See, but when I am traversing, right? When uh, temp is become a root here. Like this. Let's say this is this. So when I am here, the root becomes this in the traversal. And when I am here and this node at the traversal, the root is this. So basically, you can say root is temp only. It's used to traverse each node. Okay,
Yep.
and then we made the tree class, so we understand, okay, there are two things, then one more thing required left, right, there are two pointers required, that's why I wrote left and right. Data, so obviously we require class tree node, and then we wrote the constructor. And then I told you there are various kind of trees. Could be null. It could be like this, a very big tree. And we talk about whenever we create a data structure, there are two things we have to keep in mind: traversal and their efficiencies. It could be efficiency, it could be time and space. And then this could be security, recursion. We talk about basic recursion revision. Let's say so how to do that recursion? So there are two methods we already know to calculate the sum of natural numbers. But we wrote a recursive code. So we know if I know the n minus one answer, can I get the n answer? That is the question. Similar question is here. Can I know for one null node? Can I know the answer? This is the base case, right? This is the here n equals to one condition. Similar. I know the answer when I reaches a null node. I just need to return that I know. So then, so this will do no problem here. Our computer is very smart. It will do it. So just if it is a pre-order, the root will come, then left will come, then right will come. So we printed the root first, and then we call the left function, and then see when it reaches here, the control reaches here. It will again go like filled in a stack order. We will discuss how it's going to print a particular tree in the next class. So yeah, and then this
Okay.
is a small change here in the postorder traversal, left, right, root, and yeah, just a small change here. This order changes. Firstly, we call the left and right and the data. So yeah, this most on that. Tree is a very good topic. You need to. We will go through deep dive to it. How it's traversing. Like suppose you give a one, two, and a tree. Maybe in your exams they could ask write the post order traversal of this because you don't have a
Yeah.
computer there, so you have to write it manually. So you know should know the algorithm how it works. So yeah, we'll discuss this. Yeah.